You've all been there, right? You've got this massive data set, you're ready to do some amazing work, and your computer just freezes. What if the answer wasn't a bigger, more expansive machine, but a totally smarter way of doing things? Well, today, we're going to dive into PySpark, the tool that's all about taming big data.
I mean, it's a classic problem. You've got a powerful laptop, you're excited to dig in and find some incredible insights. But the data set is just so huge, you can't even load it into memory. It's a really frustrating wall to hit, and honestly, it's becoming more and more common.
Think about it. Your high-end laptop, maybe it's got 32, maybe even 64 gigabytes of RAM, and that's pretty respectable. But what happens when your data file is 128 gigs, or a terabyte, or even more? Your single machine just can't do it. It's physically impossible to load all of that into memory at once.
So this is where we have to totally change how we think about the problem. The answer isn't a bigger computer, it's a team of computers all working together. And that's where we get to say hello to PySpark.
The big idea behind all of this is something called distributed computing. Instead of one computer trying to lift this impossibly heavy weight by itself, you get a whole group, a cluster of computers. Each one takes a small piece of the data and works on it at the exact same time. It's literally teamwork for data processing.
So what's the engine that's making all this teamwork happen? Well, that's a technology called Apache Spark. You can think of it as this incredibly powerful, super fast engine that's built from the ground up to manage this kind of cluster computing.
And when I say fast, I am not kidding. Spark can run jobs up to 100. That's 100 times faster than older big data technologies like MapReduce. That is an absolute game changer.
Okay, so Spark is the powerful engine, but how do you actually drive this thing? Especially if you're a data scientist or an engineer who loves working in Python? Well, that's what PySpark is for. It's the user-friendly Python interface, the API, that lets you conduct this powerful orchestra of computers using a language you already know and love.
All right, so we've got this incredible, powerful distributed engine. Now what? How do we actually, work with the data? The answer is PySpark's most important tool, the DataFrame.
And this right here is a huge sigh of relief for anyone who's ever used the Pandas library in Python. The PySpark DataFrame is, and this is a direct quote, pretty much similar to the Pandas DataFrame. That familiarity is the secret sauce that lets you get up and running so quickly.
You can see it right here when you compare the commands side by side. The concepts are almost identical. They're just adapted for this new distributed world. So instead of .head to peek at your data, you use .show. Instead of .info to check your data types, you use .print schema. The fundamental difference, of course, is that one is working on data that has to fit on your machine, while the other is working on data that's spread out across a whole fleet of them.
And of course, all the core functionality you'd expect is there. You can do all your standard data wrangling, reading in massive CSVs or Parquet files, selecting and filtering columns, adding or dropping them, dealing with missing values, and doing really powerful grouping and aggregation operations.
Okay, data wrangling is one thing, and it's super important. But let's be honest, this is where the real magic happens, when you take all this power and you apply it to machine learning. This is where PySpark just completely changes the game.
See, PySpark comes with its own machine learning library called MLlib, and this is where it gets really cool. MLlib lets you build and train complex machine learning models on data sets that are just ridiculously large, way bigger than anything you could ever dream of handling on your own computer.
And maybe the best part is that the actual workflow is going to feel super familiar. You start by assembling your features, basically just bundling all your input columns into a single package for the model. Then you do your classic train test split, you train the model itself, and then you evaluate how well it did. It's the standard ML pipeline you already know, just, supercharged for big data.
So, think about this for a second. Predicting someone's salary based on their age and experience, that's like the hello world of machine learning problems. But with MLlib, you can solve that same problem on a data set with literally billions of records. That's how you find those tiny, subtle patterns that are invisible at a small scale, but can totally revolutionize an industry when you find them.
Now, this isn't just some cool academic tool. This kind of power is a fundamental, must-have skill in the tech industry today. So let's take a quick look at where you'll find PySpark out in the wild.
Seriously, if you are working with data in the cloud, you are going to run into PySpark. It is a cornerstone technology on all the big players. Databricks, AWS, Azure, Google Cloud, you name it. Knowing PySpark is pretty much essential for any modern data role. And you're going to hear the name Databricks pop up a lot in this space, and there's a really good reason for that. It was founded by the people who actually created Spark in the first place. The whole platform is an entire ecosystem built from the ground up to make working with Spark as easy and powerful as possible.
So, this really brings us full circle, doesn't it? PySpark gives us the power to break past the physical limits of a single computer. It lets us analyze and build models on amounts of data that feel practically unlimited. And that leaves us with one last, really exciting question to think about. What massive, world-changing questions could you answer if data size was no longer a problem?